Welcome to The Explainer. Today, we're going to pull back the curtain on the invisible team of devices that makes the internet actually work. We're going to break down the hardware that powers our digital world, and we're basing all of this on the awesome foundational knowledge from Jeremy's IT lab.
It's something we do every single day without even thinking about it, right? But how does it actually work? The second you hit play on a video, your request takes off on this incredible journey. It has to pass through a whole team of digital traffic cops, mail sorters, and even security guards. And today, we're going to meet every single one of them, step by step.
So, to wrap our heads around these huge global networks, we've got to start small. I mean, really small. So let's just forget the internet exists for a second. Picture the most basic network you can imagine. Just two computers hooked together with one single cable. Believe it or not, this super simple setup holds the key to understanding everything else.
Okay, so in any conversation on a network, one device has to kick things off by asking for something. We call that device the client. And that could be your PC, your laptop, or, the smartphone that's probably in your hand right now. The client is always the one doing the asking.
And well, if the client is the one asking, then the server is the provider. It's that simple. This is the device that's holding the file or the web page or the video, whatever it is the client wants. It just sits there, listens for requests, and then provides the service. Easy enough, right?
So this is the really crucial point. It's all about this simple back and forth relationship. One asks, the other provides. Think about something like AirDrop, when you're trying to get a video from a friend's phone. When your phone asks for that video, your phone is the client. And your friend's phone, the one that's actually giving you the video file, well, in that moment, it's acting as the server.
And get this exact same thing is happening right this very second. Your device, whatever you're watching this on, is acting as a client. It's sending a request out through that big mysterious cloud we call the internet, and it's asking a massive YouTube server somewhere out there to please send you a stream of this video's data.
Okay, so connecting two devices, that's easy. But what happens when you need to scale up? I mean, think about an office. You can't just run a separate cable from every single computer to every other computer. That would be an absolute mess. Just a nightmare of cables. And this brings us to our very first big networking problem.
The solution is this really cool device called a switch. The best way to think of it is like a super smart local mail sorter for just one office building. Every computer plugs into this one central box, and the switch makes sure that a message from, say, PC number 1 gets delivered only to PC number 2, and it doesn't bother everybody else on the network.
So let's look at the official definition for a sec. The key word you really need to focus on here is within. A switch is the absolute heart of a local network. Its entire job, its whole reason for being, is to manage the conversations happening inside a single location. It's all about efficiently connecting the devices in one room or on one floor.
And that whole collection of locally connected devices, well, it has a name. We call it a LAN, which stands for Local Area Network. Your Wi-Fi network at home, that's a LAN. An entire office floor all plugged into a switch, that's a LAN too. It's really just any group of devices that are all together in one physical spot.
And because a switch is built specifically for this job, its design makes total sense. It has tons of ports, you'll often see them with 24 or even 48, so you can plug in a whole bunch of computers. But here's its key limitation. It only understands the local language, It has absolutely no idea how to send a message to a different network. It just doesn't speak that language.
So that brings us to our next big challenge. Our switch has built this fantastic little local community in our New York office, but it's basically an island. It has no way to get a message across the ocean to the company's other office over in Tokyo. For a job like that, we're going to need a completely different piece of hardware.
And to solve that problem, we bring in the router. So if the switch is the local mail sorter for one building, the router is like the main post office for the entire city. It is the official gateway that connects our private local network to that vast public network we all know as the internet. And that's its one single crucial job, connecting different networks. A router could not care less about the little chat happening between PC1 and PC2 in the same room. It only cares about one thing, taking a message from your LAN and figuring out the absolute best path to get it to another LAN, wherever that might be in the world.
And again, its design totally reflects this job. A router usually has way fewer ports than a switch. And you might ask, why is that? Well, it's because it isn't built to connect dozens of individual computers. It's built to connect entire networks. So you'll have one port that connects to your whole local LAN and another one that connects you out to the rest of the internet.
And this comparison just illustrates the fundamental difference so perfectly. A switch manages the local neighborhood traffic. A router, on the other hand, is the highway system connecting all the different cities. You absolutely need both of these for a modern network to even function.
Okay, so our New York office is now connected to the whole world through its router. That's awesome! But by opening a door to the internet, we've also created a pretty big security risk. How do we stop unwanted visitors or even malicious attacks from waltzing right into our private network?
The answer is a firewall. This is a specialized security device that we stick right at the entrance to our network. You can think of it exactly like a digital security guard, and its job is to inspect every single piece of data that tries to come in or go out.
A firewall works on a really simple but incredibly powerful principle. It has a list of rules, kind of like a guest list for a party, and it checks every single data packet against that list. If the packet is from a trusted source and it's going to an allowed destination, sure, it lets it pass right through. But if not, nope, it gets blocked right at the door.
Now, you can technically place a firewall on either side of your router, but its job is always the same. And while some are pretty basic, the modern ones, what we call next-generation firewalls, are unbelievably sophisticated. They can do things like identify specific apps or even spot the telltale signs of a cyber attack while it's happening.
And firewalls really come in two main flavors. You've got the big ones that companies use, powerful hardware devices that protect their entire network. But you also have one right on your own computer. That built-in software, like Windows Defender, is a host-based firewall. It's like a dedicated, personal security guard just for your machine.
And there you have it. That's the whole team, working together. It all starts with a simple conversation between a client and a server. Then, a switch manages all of those conversations happening locally. A router connects that local network out to the rest of the world. And a firewall stands guard to keep the whole thing safe. Each device has its own critical, totally distinct role to play.
You know, the most incredible part of all of this is that the entire chain of events, your client request, getting routed across the internet, filtered by who knows how many firewalls, and delivered by a server, all of that happens in the blink of an eye. It's this silent, invisible dance of technology that just works. It really makes you stop and wonder, doesn't it? What other incredibly complex systems are running all around us that we just take for granted every single day?